Okay, so I wanted to slowly go over this Chapter 5 summative test because it's a very important one, and a lot of you struggled with it. Now again, you're creating functions and lines out of these stories. So we have the story of a bag of marbles, which contains purple and yellow marbles. The bag has 3 times as many yellow as purple, and it has 164. So write an equation or system of equations to determine how many of each color is in the bag. There's different ways to do it, but you could just look at it, okay, here's a bag, right, of marbles. And in the marble, you have 3 times as many yellow marbles as purple. So you have, I guess you could say yellow, 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 and then you have a purple, right? So in a way, you have, there's 3 times more yellow than there's purple, and altogether that makes 164. What you could do is you could simply just say, well, it has 3 times, and just give a letter for it, 3 times as many yellows as purples. Together, it equals 164. Write an equation or system of equations to determine how many of each color of marble is in the bag. Define your variables and expressions. Show how you checked your answer. There are different ways to do this, and this is what I kind of did is I just imagined, well, it's almost as if there are 4 groups of yellows, and they equal 164. Then I divided the 164 by the 4, and then I got a y equals 41, right? What did that tell me? This is just, like I said, one way to do it. If there are 3 groups of y and 1 group of purple marbles, but there's 3 times as many y as purple, it means there's almost like there's 4 groups of marbles that have the same amount of numbers. So you could take 164 and divide it by 4. Now you know that, okay, well, 1 group is then worth 41. Correct? Which is what we discovered here. We took 164, we divided it by 4 because there's 4 groups, and therefore there are 41 purple marbles. To find how many yellow marbles, then it's simply taking 164, subtracting it from 41, and you get the answer, which is 123. So there's 123 yellows, and there is 1 group of 41 of purple. And then you can also see, well, does this make sense? And it does, because if we say 41 times 3, it's going to be 123. It's going to give us the same answer as here. Okay, and which agrees with this statement that the bag has 3 times as many yellow as purple. This is one way to work it out, okay? Another way to do this, of course, is simply do a guess and check table. Okay, you have 3 groups of yellow and 1 group of purple, and together it makes 164. So now you can start guessing. Well, let's just say, for example, let's just guess something that we know it's not going to work. Let's say, well, okay, there's 3 yellow marbles. There's 1 purple marble. Together, that makes 4. So that is obviously not 164. All right, so let's guess again. Let's say there are, let's go up. Let's say there's 100 yellow marbles. All right, and if there are 100 yellow marbles, that means there would be 1/3 of that. Now this is something like 33. Okay, oops, extra 0, 33.3. Well, we know that 33 and 100 is going to be 133. So that's not even close to 164. So let's jump it up. Let's jump it up to 120. All right, so a third of 120 would be 40. Now then we're getting pretty close. Together, this would make 160. Again, that doesn't work because we need 164. So we're missing just 4. Oh, well, if we add 3 here, 123, now we know that a third of 123 is 41. And when we add those together, we're going to have our answer. And we got it. Boom. So that's one way you could also do this. Again, here we're in expressions, okay? And this is simpler than you think. Some of you got this right. Others of you struggle with this. Aquatown charges $450 to get into the park, and then it charges 75 cents for each ride. If we're going to write this as an expression, you got to realize, well, the starting cost is what, is $450. $450 is the flat rate that you pay. Therefore, that is going to be our flat rate. Nothing changes. What changes, though, is how many rides you take. If you take 10 rides, then the price will be 10 times the price per ride, which is 75 cents. Okay? So, plus the $450 for the entrance. You only enter once, right? Into the park. So you only pay that once. Therefore, this is going to be our, what we call the y-intercept. If we write our equation like this, y equals mx plus b, 450 is b. 450 is where x is where y or x is 0, right? So it's going to be up here somewhere, and it's growing by 75 cents. Each time you buy another ticket, your price goes up. Actually, there won't be any negative points here. So your graph will look something like that. All right? There will be obviously no negatives. Okay? So our expression here then would simply be 0.75x plus 450. What world's expression? Hopefully you figured that out. The price for admission, the price to get in, is $250. The price per ride is $125. Therefore, it's going to be 1.25x. Okay? Plus the $2.50 to get in. Okay? So, for example, if you ride this in wet world, you ride twice, it's going to be 1.25 times 2. If you ride it 10 times, it's going to be $1.25 times 10 plus the entrance fee of $250. Now we have our two expressions. When will they be equal? Solve the equation. You simply take these equations, and we're going to do our equal values method. Okay? Equals 1.25 plus 250 x. Now we bring our x's together and our ones together. We have $1.25 here. We break this over because this is the smaller number. So it's going to be 1.25 minus 75 cents. That's 50 cents. Then we take the $2.50 and we bring it onto the other side. It's going to be minus 250. So we're going to have 450 minus 250. It's going to be $2. All right. And we have $2 equals 0.50 times x. Now we simply divide. And x will be 4. What does this mean? It means when you have done 4 rides, the lines will connect to one another. And if x is 4, then we can simply plug it into any of these x's to get what it will cost when they are in the same, when you have done 4 rides, what will the price be? So as you can see, I just take the 4, I plug it into one of the expressions. So 75 cents times 4 plus 4.50, and our answer will be $7.50. And that's where they're going to meet. So if this was 7.50 right here, we know the two lines would meet at about there. Okay? They would meet at the 4th ride. They would have the same price at the 4th ride. So we just simply use equal values methods to solve for x and figure out y. That's all we did for this story. That simple procedure is the same we would use for number questions 3 and 4. Hermes has 8 envelopes labeled X plus $218. Apollo has 5 envelopes labeled X and $521. Each envelope has the same amount of money in it. How much money must be in each envelope? Well, we put them into an equal values method. We do our algebra, so we're going to end up with 3x equals 303. Therefore, x equals 101. So they each have $101. Again, same procedure for this question. Okay, he has $15 a month and 20 minutes per minute. Okay, therefore, per month he pays 15 bucks. For every minute he's on a line, he pays 20 cents. Therefore, that expression is going to be 20x. That expression per month is going to be 20x plus 15. Calvin signed up for another plan. He pays $25 a month and $10 per minute. So that's going to be 10x, 0.10x. Using the variable x, write an expression, which we did. Use a 5 to solve when their costs are the same. You can either do equal values method like this. It's probably the easiest. And then you just take your variables and you bring them across doing inverse operations. So you're going to have 10x equals 10. Right? 25 minus 15 is 10. So x is going to be 10 divided by 0.10. Okay, our fractions, which you all love so much. Again, fractions, it's so key. It's kind of simple. I'm going to put them all in a different color, all the numerators in a different color. Okay, we have our 2 over 5x plus 1 over 3, okay, equals 1. Now, the best thing to do is simply to, and 1, we can also say 1 is the same as 1 over 1, right? It's the same thing. So basically, if we're going to be combining all these fractions, the easiest way to do it is to make all the numerators the same. Did I get that right? The denominators. I mixed that up. It's the numerator on top, denominator on the bottom. Let me make this the right color. Numerator and the denominator is on the bottom. Okay? So the denominators need to always be the same. This is 5, 3, 1. They are not the same. So let's look at what does 1, 3, and 5 have in common. They all have 15 in common. 5 goes into 15 3 times, 3 goes into 15 5 times. So the key thing here is let's just change all of this to 15, right? So we're going to multiply this in every number by 15. We're going to multiply this by 15, that one by 15, and that one by 15. But if you think about it, what that's doing, it's basically 15 times 2 divided by 5. I'll write this out for you. I'm just going to use one color, black. Now we'll do green. So we have 15, okay, times 2 divided by 5. and we have our x, but we're just going to leave that out for the moment, plus 15 times 1 divided by 3 equals 15 times 1 over 1. Now, if you look at this, 15 times 2 is 30. 30 divided by 5 is 6. So we're going to have 6 right here. Plus 15 times 1 is 15, divided by 3 is 5, equals 15 times 1 is 15, divided by 1 is 15. Don't forget our x. Changing the colors right now. That's 6x plus 5 equals 15, right? Now, to combine, get the x by itself, you simply take the 5, we subtract the 5 on this side, subtract the 5 on this side. I'm going to move this whole thing up here. Now we have 6x equals 15 minus 5 is 10. Okay, we divide by 6, x equals 5 over 3. Okay. If you remember, 10 over 6 is the same as 5 over 3 because you can simplify this fraction by 2. 2 goes in 10 5 times, 2 and goes in 6 3 times. So now we've simplified this fraction as much as possible. So x equals 5 divided by 3. So I hope you see how this process went. I think the real key thing that you need to start with is looking at the denominators and realizing, okay, they are not the same. We cannot add or subtract fractions until they are the same. So to make them the same, you find a common multiple, in this case 15, and you multiply every number in this expression by 15. And then you follow through with those fractions, multiplying 15 by the numerator and dividing by the denominator, and then you're going to get rid of your fractions. And you're going to have a very simple expression that's easy to solve. I'm only going to take one problem here. Let's take a hard one. Let's take C. Okay. We need to solve for m. In other words, we need to get m isolated by itself. So the first thing we have is we have this expression. And all we need to do is combine. Right? So first of all, we get rid of the brackets by multiplying. So we're going to have 3m minus 4m squared. 4m times m is not 4 plus 2m, it's 4m squared. Okay? And now we have 7 plus 4 times 8, which is 32, minus 4m squared. Okay, I think now you maybe see where we are. We have got rid of our brackets, and now we're at something a little bit easier. I'm going to put our line down in the middle. All we need to do is bring our variables together. What you're going to realize something. When I bring this over, it's going to become a positive 4m squared, so it's going to obviously cancel that out. Now we can simply combine 7 and 32. We're going to have 3m equals 39. Now you recognize, hopefully, all we got to do is divide, and we have our answer. M equals 13. That's it.